the difference between a traditional drum roaster and an IMF hot air drum roaster. Stick about and I'll talk you through it. G'day, Luke here from IMF Coffee Roasters. Welcome back to our YouTube channel, where we guide you through all things coffee. Now, if you love our channel, make sure you hit that like button and subscribe and the bell so you get notified when we put up our latest video. And if you've got a question, please put it in the comments below. We love to answer them. So today we're talking about the difference between a standard drum roaster and the IMF. We're going to be covering the technology behind the heat source and how that actually gets into the beans. So when we talk about roasting coffee beans, there are two main principles of heat transfer. There is convection and conductive. So the conductive is when the bean itself actually hits the outside edge of a drum and is touching that, and it is receiving the heat because that drum is metal and it's hot. That's the same as a sausage on a barbecue. That plate is hot, the sausage touches it, and essentially it cooks the sausage. The other is convection, and that is the environment that a bean is floating around in that has a heat source to it essentially, or a higher temperature that we can adjust throughout the roasting. So in roasting, we do actually have the principles of convection and conductive at the same time, but we want to be able to control those. And the biggest difference between a traditional drum roaster and an IMF hot air roaster is that there is far more control and better airflow on the convection side rather than the conductive side. So let's go and have a look at what the traditional roaster looks like so I can explain this further for you. So this is a conventional roaster, and I just want to point out a few of the items that actually make it work. So what we've got down here is a fan motor, which is actually going to suck all of the air out of the heated beans. We've got a motor that's going to be running the drum here, and we've got a fan motor. At the back we have our chaff collector. In here we have our burner, and then we've got our controls on the front here. So what this roaster is doing is essentially, in under here we've got a big gas burner, an upgraded version of your barbecue burner essentially, and you can see that there is a drum up under here, and it's providing a heat source straight onto that drum, and that will heat up over time, and we can modulate the heat on that actual flame from this gauge and just by using a dial. So you can increase the heat at the start when we want to really start getting some energy into that bean, and as we taper it off towards the end of the roast, we would be decreasing that heat so that it doesn't burn the beans too quickly. And as far as that is the conductive side of the roasting. So where does the convection side come into it? It's all from this fan here, and what it's doing is trying to suck that heat up through the back of this drum, which actually has some perforations in it. It's pulling air through the beans as they're jumping around in the air from basically a mixer inside the drum, a couple of big paddles there, and it's coming up through this top chamber, through this tube, and we can then modulate that amount of air. So we can either close it right off and a paddle will come across and stop that air from being sucked in, or we can open it up fully or halfway, whatever we choose. And essentially that's taking the excess heat back to our chaff collector and then out the exhaust. So it's quite a easy way to have a heat source and produce a good environment for beans to roast in that we can actually change from our roasting from start to finish. So that's how a drum roaster works. So let's go take a look at the IMF. So from this side, the IMF roaster looks quite similar. It does have our front hot plate, the drum, and this entry level for beans to come into, but it's not how it actually gets its heat source like the other roaster. Now, if you want to know more about this whole roasting facility, check out our other video. We'll leave you a link. Let's go around and have a look at the back here, and we'll talk about the heat source and how it enters this drum. So this is an afterburner. Now, a lot of roasters don't have afterburners, but essentially what it is a big burner that is running at about 600 degrees, and usually it's used to condition the smoke and the odors from a roaster so that when it goes into the atmosphere, you don't get any smell and affect your neighbors essentially. But what IMF does here is actually injects this heat, very clean, beautiful air, into the actual roasting drum. So if we look up here, we've got a tube, and you can see this pivot point. That is a really big paddle which essentially will open and close, allowing the heat to actually go straight into the roaster. Now, we don't want to put 600 degrees heat straight in. So underneath here, there is actually an air inlet. And I can actually feel the actual sucking coming up through these pipes because there's atmosphere outside. So cold air is being sucked in here, and it is mixed with the hot air, and it is then pushed in through, as you can see, through the back of the roaster here. So it comes down into this tube. So it's going straight into the beans, and this is a temperature probe. And basically we are asking this roaster to deliver us a certain amount of heat at any time throughout the roast. Now that could be 600 degrees, it could be 0 degrees, and it will just continually to modulate through this here, which is called a vortex system. So we've got a huge amount of heat source on demand at any time we like. It's just, we've just got to ask it. Just give us some heat, it gives it to us. So it's very effective. It is a huge amount of massive heat that we can inject straight into those beans that's going through the actual beans. Then that heat would be residually being on the actual drum. So it's going through beans and outside the drum, the heat. That heat then actually gets reticulated back through the roaster, and I'll show you that on the other side. So the heat is then coming through this drum and then out through into our chaff collector. And that's where all that fine particle or husk will actually end up through this little bag at the back here. Now, that extra heat will actually then go back inside through this tube and back into the afterburner. So it's a full reticulating system, which makes it very effective for creating a heat source, and then there's very little waste going out to the atmosphere. So there's a good overview of how the heat source works on an IMF roaster. Now the guys at IMF actually have an amazing video that can show you digitally where the heat sources come from and how they go through the roaster, so we'll leave you a link below so you can check that as well. And what I wanted to cover, one last thing, is this is an IMF roaster that is a drum roaster that has a hot air flow or hot air source. So look, there are hot air roasters which work very different again, but I really wanted to make it clear that this is not an underneath style gas flame burner trying to heat a drum with that huge conductivity style heat force. So I hope you've got something out of this video. If you've got any other questions, please shoot us a comment. We'd love to hear from you. Thanks very much, guys. Have an awesome day.